In this lesson, we're going to start to talk about relations and inverse functions. What you can see up here, a relation, this is a term we used a long time ago, so if you forget what that means, it's just a set of ordered pairs. We don't know anything about them. They could be a linear, make a linear graph, they could make a quadratic graph, they could make no pattern whatsoever, just three random points. So when we don't know anything about them, we just call them a relation. An inverse relation, then, is the set of ordered pairs obtained by reversing the coordinates of each ordered pair in a relation, which is a really fancy way of saying you flip x and y. So you can see that we have 3, 7 as our first ordered pair. The inverse of that would be 7, 3. 2, 6 is 6, 2. 0, 4 is 4, 0. So that concept of finding an inverse is when you are going to flip the x and y variables to find them. So using that, we're going to do problem number 1. It says here's our relation, let's find the inverse relation. So I'm going to flip my x and y's. Instead of 1, 3, I have 3, 1. Instead of 6, 3, I have 3, 6. Instead of 6, 0, I have 0, 6. And instead of 1, 0, I have 0, 1. So I have literally flipped x and y. They ask you to plot the points of the relation with dots and the inverse relation with x's. So the first relation I'm going to use dots. So I'm going to plot what they were originally gave me right here. So 1, 3, 6, 3, 6, 0, and 1, 0. See, it makes a little bit like a rectangle there, right? I'm going to now use crosses, or x's, to plot the inverses. So my inverse is 3, 1, 3, 6, 0, 6, and 0, 1. Again, kind of a rectangle, right? So here's the thing that we want to notice about inverses. It tells us to graph the line y equals x. The line y equals x has a slope of 1 and a b of 0. So that line is always the one that actually cuts your graph in half. So I'm going to just graph it as a dashed line because it's not part of our answer. That's this line right here. That's the line y equals x. So what I want you to notice now is across that line, I want you to see what's happening with all of those ordered pairs. So notice right here. Do they appear to reflect across that line? There's a good geometry word. Take a look at each one. Hopefully you're noticing that if I folded, let's say this was on your paper, and you could do this right now even with your notes. If you fold your paper on this line, the x's and zeros will be touching, right? So that's what we say, it reflects across the line y equals x. That's true for all of our inverses we're going to do. So these are inverse just points. They don't make anything. We're not connecting the dots. I mean, we say they make a rectangle, but they're just connected there. If we're going to actually try to graph lines and things, we're going to see that they also reflect across this line. So with that, that leads us into inverse functions. What I want you to pay attention to is if we call a function f of x, which would be kind of hard to see, the inverse function is noted here as f to the negative 1, it looks like, and we would read this as the inverse function of x. So that's how you read that. You wouldn't say f to the negative 1 of x. That's read as the inverse function of x. So to find an inverse function, we switch the x and y, or the y and x as it's read, and then we solve for y. So one thing to remember is that f of x is just like writing a y for us. It's not exactly the same thing, but we can say that that's our y variable. F of x is our y variable. It's our dependent variable. So we sometimes just think of it as being the y. So for our first problem, it says find and graph the inverses. So they give us an original problem. So this problem is f of x equals negative x plus 2 divided by 2. I purposely wrote it like this because you will see it written like this a lot. This isn't necessarily how we normally write our equations in slope-intercept form, though. If we were going to write this, I would actually write it like that. So I'm going to replace the f of x with a y, so I realize what I'm switching. And then I'm going to actually divide them both by 2. So we would have written this as negative 1/2 x plus 1. So we know that our slope is negative 1/2 and our b is 1. Before I find the inverse, I'm going to actually graph this line. So I'm going to graph my function with red here. So I would start at my y-intercept of 1, and then I'll move with my slope of negative 1/2. So down 1, right 2, or up 1, left 2. Connect the dots. Hopefully you have a straight edge. I'm going to try to use straight lines because my lines get pretty bad if I try to graph myself. That one's not too bad. So there's my line. And on your graph, I would like you to label this as f of x. So we know that's our original function. Then to find the inverse function of x, I'm going to actually take this equation and I will flip-flop the y and x. So I'm going to write x equals negative 1/2 y plus 1. And then we'll solve for y. So I want to get y by itself in order for me to graph it. So I would minus 1 from both sides. X minus 1 equals negative 1/2 y. And then I can either divide by negative 1/2 or times by negative 2. So I have negative 2x plus 2 equals y. So I would write this now as the inverse function of x equals negative 2x plus 2. And they asked me to find this, so that's actually my answer for part B here. And then I'm going to actually graph this line. So I'm going to start with my B again, and I'm going to use a different color here. So I start at 2. My slope is negative 2, so down 2, right 1. Or up 2, left 1. Again, I'm going to connect my dots with a line. And then I'm going to label this the inverse function. So we know which one was the original, which one's the inverse. You might not notice too much about these, but let's again put in that line y equals x. So I'm going to do that as a dashed line again. Make it a little bit more exact. There we go. So now take a look at this line. If I was to fold my graph along the line, the dashed green line, do you see how the lines would line up? They'd touch each other. And I'm a little bit off because I didn't make mine perfectly straight. Ideally, I would have had this part probably be on that line. But it's fine. It's going to get the job done for this. So it's kind of, it's a sketch when you do it by hand. But you can see that these functions, these linear functions here, still reflect across the line y equals x. And that's what should happen with all of your inverse functions. That's what we want to notice about them. So let's try one more. I want you guys to try this one. Graph it right away because it's already set up for you. And then you can find the inverse, graph it, and see if it reflects across that line. So go ahead and do that one, and then you can check mine to see if it's the same. So graphing this, I start at 5. My slope is up 4 over 1, which doesn't fit on my graph, so I'm going to go down 4, left 1. And then when I connect these dots, this is going to be a really steep graph. So let's see if I can get that right. Fix it a little bit here. There we go. That's a little bit better. So there is my function. And then if I find my inverse function, I'm going to, this is a y, right? So I'm going to flip these. And I would write x equals 4y plus 5. I'm going to go ahead and solve for y. So I have y equals 1/4 x minus 5/4. When I write this, I want to write it as the inverse function. So I'd say the inverse function equals 1/4 x minus 5/4. Not extremely excited about this one because I have to graph with a fraction as my y-intercept, but I can do that. I would realize if you were doing this on your own that you might be a little bit off. So negative 5/4 would be negative 1 1/4, so maybe right about here. And then I have to go up 4, right 1. Or excuse me, up 1, right 4. So up 1, right 4 would be right here. And down 1, left 4 would be right here. Make my line again. Double check how that looks. That one's actually not too bad. We'll leave that one. My arrows, and I'm going to label it the inverse function. And I've gotten that part done. So lastly, we're going to put in the line y equals x again. There we go. And hopefully, Look at, this one's even a little bit better. We did pretty good on this one. If I fold along that dotted dashed line, my lines would be touching. So that shows how they reflect across a line y equals x.